In this video, we're going to take a look at some algebra ideas. In particular, we are going to look at some ideas related to graphs. And in the following videos, we'll look at some other algebra and trig reviews that's going to be important as we go through Calculus 1. But let's jump into some ideas about lines, just recalling some definitions that we have seen before. Right, so when we look at the slope of a line, right, that slope of a line through 2 points, x1, y1, and x2, y2, that slope is simply the change in y over the change in x. Notationally, we will write this with this notation right here. So we have delta y, which throughout calculus, when we talk about delta, delta is going to mean the change in, right? So this is the change in y over the change in x. And so that's the slope, right? It's just the change in y over the change in x. When we want to write the equation of a line, there's a variety of different ways that we might write an equation of a line. So one way we could write the equation of a line is if we know the slope and we know the y-intercept, we can use this form, y equals mx plus b. Right? That's our slope-intercept form for the equation of a line. I would guess this is the equation that many of you are most familiar with. Teachers tend to choose this one, prefer this one. At least in some of my formative years, they preferred this. I think it's because this writing, the way you would write that equation, is unique. There's only one, but it's not the only way that we could write the equation of a line. So another way that we might write an equation of a line is we can use, if we happen to know the slope, right, just like we did above, and instead of knowing the y-intercept, we just know some other point, so let's call that x1, y1. If we know that, then our equation is y minus y1 is equal to m times x minus x1, right? So this is an equation. The y is still a variable right there, but the y1 would be an actual number. The value x is still a variable, but x1 would be a number and m would be a number. Right? So if you happen to know your slope was 3 and you had a point was, let's say 4, 7, then the point slope form for this line is y minus 7 is equal to 3 times x minus 4. And again, this is called the point slope form because we know one point, any point at all, and we know the slope. This is the way I prefer to do this. I like to go through point slope form. If you happen to have the y-intercept, then this value right here would be 0, and you could just distribute things and you would get to the slope-intercept form very quickly. If you started here from point-slope form, you could solve that for y and get to slope-intercept form very quickly as well. If we have a line that is a vertical line, right, so it's going up and down, for vertical lines, your x value is fixed, and so your x value is just some number a. And so that's that equation for the slope, or the value for the slope, is undefined. So the equation is just x equals a. It's not a y is equal to something, because your y is free to be anything that it wants, as long as your x value is whatever number that happens to be. If we're talking about a horizontal line instead, a horizontal line, it does have a slope. Its slope is 0, and so then its equation is y equals b, right? So you could come back up here. You could think of it as slope-intercept form. Your slope is 0 for a horizontal line, and so all that goes away, and you just have y is equal to b. If you have two lines that are parallel, their slopes are going to be equal. So parallel lines have the same slope, and perpendicular lines, they have negative reciprocal slopes, which means if you start with the slope of one line, so let's say our first line has a slope of 2/3, then the second line, the perpendicular line, its slope would be negative 3/2. So you would flip that fraction and negate it or change the sign of it. So if it was positive, it becomes negative. If it was negative, it becomes positive. All right, so those are some ideas about lines and graphs that we have. In our next video, we will look more at domain and range and odd and even functions.